So I'm leaving. I'll proceed to introduction part. Banana as the world's most popular fruit, it accounts 75% of tropical fruit share, which is more than 100 billion are eaten per year. In Malaysia, banana are most produced in 2017, which is 350,000 metric tons within 35,000 hectares of land, which is account for 24% of the total fruit productions. For every tons of banana harvested, 100 kg of fruit is rejected and 4 tons of waste are generated. The waste include rotten fruits, peels, empty fruit bunch, leaf, pseudo stems, and rhizomes. However, the current disposal methods for the banana waste are open burning and left at the plantations for decades. So there is only small amount of banana waste are used as animal feeds by farmers, as well as for biogas digestion feedstocks to minimize the cost of production. Past researchers mentions that banana cultivations and industrialization generate a considerable amount of waste, which is rich in cellulose and starch, which makes the banana waste a promising source of ingredients for the productions of biodegradable materials. Also, there is several studies suggest that the component in the banana peels can be extracted, reused, and recovered as a new material due to its various characterizations. So, there are suggestions that the banana byproducts such as green cut banana peels and pseudo stem could be a potential low-cost sources and raw material of high-quality starch, pectin, and cellulose for the food industry. Thus, this research is designed to extract the cellulose from the banana peels of Musa Sabah and also to study the characterizations of the chemical compositions, chemical properties, and physical properties of the Musa Sabah.
Hi, I'm Yuxuan. I will explain about the literature review. Do you know what is Sabah banana? Sabah banana is an ABB triploid cultivator of Musa balbisiana and Musa acuminata by polyploidy and hybridization. Sabah banana have the scientific name is Musa acuminate balbisiana cola ABB group Sabah. Natural plant fiber are several that can be found in stem, leaf, root, fruit, and seed of a plant. This fiber is composed of cellulose, hemicellulose, lignin, other lipids, and water-soluble compounds. What is cellulose? Cellulose is a semi-crystalline biopolymer with ordered crystalline and disordered amorphous regions. At the same time, hemicellulose also the main component of the fiber, which is a large group of polysaccharides found in the primary and secondary cell wall. Whereas lignin is a biopolymer having a highly branched 3D structure that contains the different functional groups. There is various efficient methods have been developed by researchers in order to extract cellulose, which shown in the flowchart. The cellulose can be processed into rods, mats, bioplastic, and other applications. Thank you.
I'm JOANN and I will explain the preliminary data of this research. In the chemical composition, there are 5 types of components that found out in the banana peels, which are the total extractive, cellulose, lignin, polysaccharide, and the H. Polysaccharide are the many components that make up of 70 to 75% on a dry basis, whereas the H are the least component, which consists around 3 to 5%. In the chemical treatment, the material undergoes changing of color. The material changes from the initial brown color to the white material at the end of the hydrolysis. For the scanning and and the transmission electron microscopy, we can see that the banana peel brain will reveal the irregular structure and some residue from the grinding procedure. The presence of the cellulose can be confirmed by the TIAN image. For the particle size distribution and the zeta potential, the length of the cellulose in this distribution affected mostly by chemical and enzymatic treatment, which the length are in the range of 454 to 475 nanometer for CT and 2889 to 3105 nanometer for ET. For the zeta potential of cellulose by CT and ET, we can go through the table below. For FTIR, the functional group that present in the sample can be analyzed, which the main FTIR band that will be observed in the FTIR spectra of the brain and cellulose are shown.
Okay, so I'm Jun Kang. I'm going to talk about the methodology of this research. But before that, we will separate the procedure, the research procedure, into two stages, which is the extraction and characterization. Before the extraction, we're going to pre-treatment the banana peel. So the main purpose is to prepare the brain for extraction of cellulose. After the pre-treatment, we'll come into the chemical treatment. So the chemical treatment is mainly comprised of 5 procedures, which is the first alkali treatment, first bleaching, second alkali, and the last will be acid hydrolysis. After going through all the chemical treatment, we will now proceed to the characterization. The cellulose suspension we got from the chemical treatment will now send to variety of instruments to analyze, such as the scanning electron microscope, SEM, TEM, X-ray diffraction, FTIR, and so on.
Hello, my name is Irene, and I will be presenting the statement of limitation. There are 3 limitations in this research. The first one is the nature of the raw material. In this research, we will be using unripe banana instead of ripe banana. This is because the enzymatic synthesis of the fruit itself occurs during maturation and thus to partially degrade the cellulose to monosaccharide. And then the second limitation in this research is the property of the hydrolytic agent. In this research, we will be using sulfuric acid as the hydrolytic agent. As we all know, sulfuric acid is corrosive and it will modify the structure of the cellulose. Therefore, we can use lower concentration of sulfuric acid or replace it with another acid such as hydrochloric acid. The limitation in this research is the limitation of instrument. All the instruments have many functions, but we will be only using some of its functions in this research. For example, scanning electron microscope and transmission electron microscope will be using to confirm the presence of cellulose. And then FTIR can detect a lot of functional groups, but in this research, we only use it to find certain functional groups such as the carbonyl group, which have chemical shift of 1730 per centimeter and aromatic ring in 1500 to 1600 per centimeter. In conclusion, this research proposal proposed that the extraction of cellulose from banana peel basically involves 3 steps. The first one is pre-treatment of raw materials, the second one is partial hydrolysis, and the third one is mechanical disintegration. As for the characterization of the cellulose, we will be using SEM, TEM, X-ray diffraction, particle size distribution and zeta potential, thermogravimetric analysis, and dynamic light scattering analysis. Cellulose have many uses, such as the lignin in the cellulose can be used as a source of nanofibers. Besides that, it can be used as the reinforcement agent for manufacturing of bio-nanocomposite and for absorption portion dye. That's all from me. Thank you.